Hey, it says live. How are you guys? Everyone okay?
How we doing, guys? Thumbs up?
Look, everyone's putting the thumbs up. Because I can't hear everyone, thumbs up is always really good for that kind of thing. So thumbs up to everyone. Afternoon to everyone. It's afternoon here in the UK. It's 3 o'clock in the afternoon, so I know it's just morning for you guys, but it's afternoon over here. And we're going to take just a little bit to talk about, well, the stuff that I do. My name's Huw James. I'm a scientist. I'm an adventurer. I'm actually an astronomer by training, so I did my degree in astronomy and space science. But since then, I've been doing lots of stuff in communicating science and wondering about, well, lots of different questions. So what I wanted to do was share my screen with you guys and do a few bits and also do some experiments while we're here too, because there's a lot of stuff to be curious about. So for me, having or being curious is one of the biggest parts of my job. As a scientist, being curious has always been something that I've been really interested in. And at the moment, I'm a bit of a photographer. I go to many different places doing photography. I go to many different places doing science and many different places doing adventure. Sometimes they're very cold places. Because sometimes you have to go to these cold places to get the best kind of adventures, and sometimes you go to the nicer places. But I quite like the cold ones because, well, they're a bit nicer. They're a bit more adventurous for me. But I was recently out in the US and Alaska having some adventures, but also down in Central America. And I do lots of photography on the way because I love seeing the world through a lens. And one of the recent bits that I did a bit of photography on, I don't know if you guys saw it as well, because it was visible from around the world, but in different parts, was the lunar eclipse. And I got really interested in astronomy at a very young age, and very interested in how the world works. So what makes the world tick? And I think that if we're not curious about that, I think we're all curious about that at quite a young age, but if we don't we aren't curious about how the world ticks, then it becomes really strange. So one of the things I started doing was doing talks for people like yourselves on things like curiosity. And you guys might have seen this before. You might not have seen it. This is an actual thing that you'll learn in, well, you might not learn this one in English. I'm currently trying to get this onto mobile phones because it's called an Interrobang. And if you guys have ever used an exclamation mark, which is like you're shouting a word, and also a question mark, which is for a question, this is what you should be using, an Interrobang. And the Interrobang is something that you'd use if you really want to know the answer to a question, if you're really curious about something. And everyone's really curious about everything. Even lots of animals will be curious about stuff. Things like dogs will be, lots of mammals. It's a good sign of intelligence if a mammal is curious about stuff. Some mammals are a bit too curious about things, including squirrels. They tend to be quite curious about a lot. So curiosity is something that lots of intelligent things are born with. So it goes to show if you are curious, you're probably quite intelligent too. So if you want to be intelligent, you have to be curious. It goes both ways. So I still do a lot of stuff in the night sky because the night sky and astronomy is the thing I'm most curious about, how the universe works, how stuff works in the night sky. So I go out and do lots of photography, looking at different constellations and looking at different stars, and I do that around here, but also around the world. So one of the projects we set up was actually going to different places around the world and doing expeditions and learning about how the world works, looking at volcanoes and how they work, looking at rivers and how they work, and looking at the Earth itself, how it all interacts with each other. And you can call that geography, you can call it geology, you can call it science, you can call it chemistry, biology, you can call it whatever. It used to be natural philosophy, and people used to study all of it. So now science is kind of, once you go into upper school, if you're in upper school now, it's kind of segregated off into different types of science. But it used to be just science and a big part of it. So now we go around the world doing things like that. And we've been to quite a few places now. We went out to the French Alps recently, it's a mountain range in Europe, and we looked at how glaciers work. We did live calls like we're doing now, right through to classes across the UK and across the US, looking at how the glaciers work in the French Alps. And it's a great region, mountain building region out there. And we did a bit of climbing whilst we were there too, because, well, why not? So the first one we ever did, we actually drove for 4 days through Europe, which actually for Europeans is a big drive. I know for you Americans, it's not 4 days driving 16 hours a day, isn't that much? But actually for us, it was, I mean, a couple of hours drive for us Europeans is quite a big drive. So we spent 10 days on the volcano, looking at how the volcano works and making videos and the likes. And what we found is that there was lots of different things about the volcano that really surprised us. Things like there was lots of ladybugs. I don't know if you guys call them ladybirds or ladybugs. The little things that are red with black spots on them, and they can be men as well as women bugs. They're just called ladybugs for one reason or another. But we found that there were lots and lots of these actually on the volcano itself, and we got to thinking, and we put it back to that curiosity: why are there so many ladybirds on this big volcano? It's a 3,000-foot volcano. 3,000 meter volcano, sorry. So why would there be ladybugs all around it? And it turns out that this volcano, wind blows the ladybirds up the volcano, and then they all stay on the volcano because there's no natural predators for them. So it's something that we found whilst we were on the volcano that was really interesting and really intriguing. Another one that we did after that then was our biggest river here in the UK is actually called the River Severn. And the River Severn is a river that's 220 miles long, again, compared to the American ones, not terribly huge, but it's our largest one here in the UK. And we took stand-up paddleboards down this river to look at things like the ecology, like how the river works, how the animals interact with each other, and the geography, then how the river works its way down from the mountains right down to sea level, and also what lives in the actual river itself. And it's really interesting to look at the river. We spent 10 days paddling like 30 miles a day. So when you guys, or if you have any intention of running a whole marathon, we were doing one of those on water with our arms every single day, which looking back was actually quite crazy, because what we'll find is that when you are paddling for that long, you get really tired really quickly. So on these expeditions then, we had lots of time to do the science. We had lots of time to do the paddling, but to do it all together actually took around 16 to 20 hours a day. So we weren't really sleeping for that long. We were actually probably sleeping for about 4 hours. I'd fall asleep with my laptop on my face because I was editing all the videos until the wee hours of the morning. But it was worthwhile. It was good science, and we were curious about this river and what the river actually did. And then that time where we spent out in the Alps, then looking at the mountain ranges. Mountain ranges are always fairly interesting. These mountain ranges, and you'll get them all across the world, will have different types of mountains, different size of mountains. Obviously, the Himalayas are a bit bigger, but anything that you get above 3,000 meters will start to affect you in terms of altitude. You might start to get sick, and also, you know, it starts to get very cold above that altitude for many different reasons. So we spent a bit of time looking at the glaciers, because all the glaciers are retreating out there at the moment, as is all across the world. So actually, all the expeditions that we've done so far have just been based on curiosity. And the reason we've done them is because we've just been curious. This Interrobang feature, looking at, you know, being aggressively curious about stuff, is something that I've done since a young age, and I'm sure you guys will too. And it's all based on this thing, the scientific method. Because in class, when you learn science, actually there's no such thing as science, which is kind of weird. Your parents and your teachers will tell you that you're going to study science today, but you never really study science, because science is a tool that we use. It's a method that we use to actually study the world. So the things that I've been curious about, and that lots of people are curious about, is just stuff in the outdoors, and I spend lots of my time in the outdoors looking at different things. and I got really curious about clouds. And I'm sure you guys will all have a favorite cloud. I know you teachers will do. I always have a favorite cloud. These are some of my favorite clouds. But I've got to wondering why they actually work. And to understand why things work, then normally what you'd do is you'd have some kind of experiment. Okay, and the experiment for us is actually having a cloud but inside a bottle, right? So I thought I'd do some of my favorite experiments with you guys right here, right now. Okay, so I've set my my tabletop up to be a little lab, and for this experiment, you guys can do this too. When I was in the outdoors looking at how clouds work, people started saying to me that it's all to do with pressure, and you might see this on the news, on the weather, that pressure makes clouds. And I was like, well, how does water change from one state to another just by pressure? So I started experimenting with it. So this stuff here is just some water. Well, actually, it's nail varnish remover because it works a little bit better than water. So this stuff is nail varnish remover, and I wanted to see if pressure could change how this worked, right? So I put a little bit in the bottom, and it's easy enough to shake it up then. So I can shake this up, and it doesn't really change the state at all. It still stays as a liquid, right? So we haven't made a cloud just yet. But to do that, like I say, we need a different pressure. And the more you guys look into clouds, the more you'll look at different pressures. And to do that, I use a bike pump. And I can't actually fit this entire bike pump on in the camera because it's so big. But I can increase the pressure inside this bottle using a bike pump. Okay, this is also how you make rockets with bottles, so you have to be quite careful. But to change this from a liquid, like you would have in a lake or in the sea, to something like a cloud, you just need extra pressure. Okay, and the whole world is changing pressures at different times. And you'll see on the news, it'll say, on the weather, it'll say high pressure to low pressure. But if we give this high pressure, and all this bottle now is under high pressure, as soon as we change it to low pressure, you can see it changes into a cloud. You can kind of see it coming out the end. That's a cloud inside that bottle, right? But as soon as I put it back to high pressure, because right now it's under low pressure, I put it back to high pressure, and the whole thing disappears, right? So when I was in the mountains and having adventures and looking at clouds, all I'd be looking at is if we've got high pressure, where it's a nice day, or if we've got low pressure, where we've got a cloudy day and potentially get rain. Okay, so it's one of the things I was curious about and started doing experiments with, looking at how clouds are made and also how that affects the weather, and especially for my mountaineering and my adventures. And that led me on to look at something else, which was why the sky is actually blue. Well, the sky is blue sometimes, but it's not blue all the time. So I wanted to look at why it's sometimes blue and then why it's sometimes red. Okay, because normally you'd see the sky and it looks a bit like this. With you guys, you'd see this lovely blue sky, and you'd think it's a nice day. Oh, we just learned that that's high pressure rather than low pressure. So I wanted to look at this and look at why is sometimes red in the nighttime when you get red skies, and why you get also you get blue skies. So what I did was I made an experiment using some water and a torch. Okay, so this is just some water, and if I shine light through this, like the sun, just like the sun, then it comes out on the other side, and it's kind of blue. Okay, it's kind of blue, kind of white, like you would normally see, right? But if I add some stuff into that, in the atmosphere, they're called particulates, just bits of dust, bit of Saharan sand that gets blown around the world and creates different kinds of light. So you get a red sky at night, mostly because there's stuff in the way. There's little bits of particulates. So we're going to use for this experiment some milk. Okay, you don't normally get milk in the atmosphere, but sometimes you'll get bits of dust. Okay, so if I add a little bit of milk into our chamber, okay, that's all I'm going to do is add a little bit of milk into there. It does look really cool when you put it in. for a start. But have a look at how it affects the light on the other side. At the moment, it's completely obscured the light on the other side. And if I turn this off, you might be able to see it a little bit better. But that bright white blue light that we started off with is starting to change. Okay, and it's starting to change bit by bit because there's more stuff in the way. There's more particulates. All right, and you start to see that that's starting to change to a more orangey red light. And that's because there's more stuff in the way. So just like you get a red sky at night, when there's more stuff in the way, you'll get a red sky. And again, that was led kind of by my curiosity of how I want to look at how the world works, right? But there was one thing that I keep coming up with in my science expeditions, and it's how people aren't curious anymore. They don't ask these questions. So you guys might have seen this experiment going around online. It's called The Only Video That Coca-Cola Never Wants You to See. Right? And this is my curiosity going into overdrive, right? Because I really wanted to know, is this actually true? And I thought we'd do the experiment with you guys today. Because I've set the experiment up. I've actually never done this experiment before. And it's basically an experiment that says when you mix milk and Coca-Cola, bad things happen, right? And I know you guys will drink Coca-Cola in some way, shape, or form, some kind of soda. You probably drink milk too, right? So they put this video online, and they said all these the things that you put in your body, they're disgusting. You know, Coca-Cola you should never drink because after a while, this starts to happen. Okay. And what they found is that they start to separate out and they start to look a bit disgusting. 6 hours later, you start to get this. All right. And I thought what we do today is we do this experiment and I time-lapse it and then, you know, I'll put it up for you guys to see. So I've actually set it up over in the corner so you guys can see it. Let's go back to that. So in the corner, I've set up Coca-Cola. And you know I've got some milk because we just used it. And I've got my camera set up for a time-lapse experiment. And I thought we'd put it in, okay? So all I'm going to do is I'm going to pour in the milk, hoping that I don't drop any down the back of my desk because that'll start to smell. Okay, and as the milk goes in, you can see it already starts to curdle a little bit. And that's the acid reacting with the milk. And if we leave that for a while, it already looks a bit disgusting. But if we leave that for a while, what we'll find is that it all starts to separate out, right? And the idea behind this, for the experimenters, was that this is disgusting. What they wanted to say was that if you put Coca-Cola inside your body, then this stuff's going to happen, right? And the experiment, which is online, you can watch the videos of this, and it's basically don't drink Coca-Cola. But if you're curious enough, you'll start to wonder if Coca-Cola is actually that bad for you. What is it about Coca-Cola that makes this happen? All these things separate out, and actually, is it that bad for you? And you find that, well, actually, the thing that makes milk and Coca-Cola do that together is actually just a simple process which is involved in dairy products and acids. And actually, the stomach acid in your stomach is more acidic than that milk, than the Coca-Cola anyway. So as soon as you drink milk, that stuff's gonna happen. So it's kind of crazy that, you know, without curiosity, you can be duped into thinking lots of different things. Okay, I'm not saying Coca-Cola is bad for you. It's good for you, sorry, because it's definitely not. It is acidic, which is why it's bad for you. But don't always believe what you're told on the internet and on TV, because actually people who don't know about science can actually misinterpret the evidence, and they don't always ask why. And it's asking why and being curious that, you know, that we should always be doing. And you guys know that. You guys will go out and be curious about stuff and ask your teachers stuff, ask your parents stuff, and just keep asking those questions. And we do it on our expeditions now, but also, you know, in our everyday lives. I honestly, in my garage, is kind of full of experiments like this, just for trying out, because I'm curious about these kind of things. All right. So that's what I wanted to show you guys today about the power of curiosity and the importance of staying curious at all times. So I want to throw it back to you guys now and see if you guys had any questions, Mr. Grabowski, about anything in particular.
All right. Well, Huw, that was amazing. Thank you so much.
Thank you.
Before we do move to the Q&A, I just want to give a shout out to the classrooms we have joining us. So you can see in the background from Guelph, Ontario, we have some 6-7s joining us.
Hi, guys.
If I jump over to New Jersey, we have some grade 5s joining us from Mrs. Capone's class.
Oh, hi, Mrs. Capone's class. Hi.
There they are. And then from Sarnia, we have a class joining us, Sarnia, Ontario in Canada, Sacred Heart School, and they call themselves the 49ers. There they are.
Hi, 49ers.
Hi, Jesse.
Hey. I've got a question already, which is why the 49ers? We'll come to that in a bit, I'm sure.
All right, perfect. So let's start with our class in New Jersey. I'll turn your mic on, and why don't you ask Huw a couple questions while you have the floor.
Yay.
Well, first, can I say hi, Paige, introduce yourself.
Hi, guys.
Loud.
Hi, I'm Paige.
Hi, Paige.
And how long have you been exploring?
Oh, that's a good question. How long have I been exploring? Well, I think ever since, I'm sure it's the same for you, ever since I was very, very little, I'd go out into my back garden and I'd try to find stuff, and I would go out and I would pick up rocks and look what's under them. I remember looking for tadpoles when I was about your age, throwing rocks over my head, and one landed on my head and cut my head open, which wasn't very good. But just I was always that curious about stuff. And, you know, normally you grow up through life, and a lot of adults you'll find have grown out of being curious. Okay, and I think it's really important to stay curious. So you already know to be curious. You already know that going out and exploring is part of being curious. So even though I was exploring from a very young age, I'm sure you guys will be too. So like I said, just keep on being curious, keep on exploring. Thank you, Paige.
Thank you.
Taking a sip to you whilst we do this. Hi, buddy.
Hi, I'm Alex.
Hi, Alex.
What is your favorite adventure that you've ever gone on?
Oh, my favorite adventure that I've ever gone on. Do you know what? So my favorite adventures are about an hour away from me. We've got a national park that's about an hour away. It's called the Brecon Beacon National Park, and it is one of my favorite places in the entire world. I was up there recently. We were looking. I spent 14 hours looking at something called the Lunar Eclipse, and the Lunar Eclipse is where the moon goes behind the Earth. So you've got the sun and the moon and the Earth all in a line, and then you get this kind of thing. So I was in the Brecon Beacons. These are two of our biggest mountains, Penavan and Corndee. They're called these two just over here, and you can see the moon moving from one place to another, and when it goes behind the Earth into the Earth's shadow, it goes red. And that's all to do with light. We just saw how things that get in the way create red light, and that's exactly the same thing. So my favorite place to ever go exploring is right on my back door. It's called the Brecon Beacons, and I think always exploring right next to where you're from is always the most exciting thing. Thank you, Alex.
All right, let's snag one more from New Jersey.
Hi, my name is Jake.
Hi, Jake.
What was your longest trip you ever went on?
The longest trip we ever went on. We've got a couple set up ready for next year, out to the Himalaya and the Peruvian Amazon, which are 5 weeks in total, 5 weeks away from home. But I think the longest one we've ever done is about 3 weeks, and that was when we went down to the south to Sicily, and we spent about a week driving each way and about a week on the volcano altogether. And we were looking at how the volcano works. Unfortunately, or maybe fortunately, depends on how you look at it, the volcano didn't go off when we were there. But I would love to have seen it go off, because that's, for me, seeing a volcano go off is one of the most exciting things that you can have. But we spent 3 weeks on the road, but also then on the volcano itself. And it kind of happens with science quite a bit that you'll go on these big long expeditions, and you have to be there for a long time, because otherwise you can't get a good science. And actually, one of the trips that we're setting up for next year, we'll go there every year for 10 years, up into the Yukon. And that's because when you're doing science, you need to compare it to other science. And you can't do that without going back time and time again or doing it day after day after day. And we tell people that science and expeditions are really exciting, and we get to see great things, but actually sometimes science is really boring. But it's the boring stuff that sometimes leads to the most exciting outcomes. In astronomy, in chemistry, in biology, all of these different places and all these different things that we do, when you take in measurements time and time and time again, and some of the, especially in astronomy, we take measurements for years on end, that's the stuff then that leads to the good data and the exciting outcomes. So for me, like, science is a non-stop process, but probably 3 weeks is the longest I've spent on expeditions so far. Until next year, we will spend 5 weeks in the Yukon.
Thank you.
Thank you very much. Cheers, buddy.
All right, great questions. My
Amazing.
class 2 years ago, grade 6, we were very lucky. We got to connect with Huw from Mount Etna for a lesson, so that was a real special experience for my students 2 years ago. Let's visit Sarnia, see if they have a couple questions for us.
Hi, Sonia.
Hi, I'm Rachel.
Hi, Rachel.
I was just wondering, where is a place that you want to explore that you haven't explored yet?
Oh, let me ask you first. What's the place that you haven't explored that you want to explore yet? So next.
I want to go to London, England.
London, England. I'm going there on Saturday. I go there quite a lot. It's only 3 hours from me, so it tends to be where lots of stuff happens in the UK, because it's the capital. London, UK is fantastic. We're actually doing an online series with Lonely Planet Kids, all to do with different cities, and our first one is in London, England. So I'll send you the video when that comes out. But for me, the one place I haven't explored is the North Pole, mostly because the estimates of how long the ice is going to be there, because on the North Pole, where you stand and you look directly above you and the North Star is there, the North Pole is just sea. So there's no land there, there's only ice, and you can only walk there in certain seasons, normally in winter. But we reckon by 2050, which isn't that far away, it's about 35 years time, there might not be any ice at the North Pole, so you might not be able to walk to the North Pole anymore. So for me, there's a real time scale on that. So I want to go as soon as I can, because we're not sure how long the ice is going to stay at the North Pole. So North Pole is up next.
All right, thank you.
Thank you very much.
Hi, I'm Ava.
Hi, Ava.
Is volcanoes your favorite thing to explore?
Oh, that's a good question. Volcanoes. Have you ever been to a volcano?
No.
You've got to go. They are amazing places to be, because you kind of get the sense of the Earth is alive. It's a living place, and that actually what makes our Earth different from most of the other places in the solar system. That it's a dynamic planet, and it's a little bit like Mars, but the fact that it moves around makes it a bit special. So for me, when you're exploring a volcano and you see it go off, you feel really small. And luckily, well, I say it didn't go off with lava when we were there, but it did go off throwing smoke out. And I was on a call to a school in Nebraska, and it went off behind us. We all got excited. But you get a real sense of that you are part of a bigger thing. And I like that about geology, about volcanoes, about astronomy in general. It gives you a real sense of where you fit in on our planet and in the universe. So I think, yeah, volcanoes probably one of my favorite.
Okay, thank you.
Thank you.
Great questions. Let's steal one more.
Amazing, yeah.
Anybody?
Take your time. Who's up next? Oh, hi, mate.
Hi, I'm Carter.
Hi, Carter. You look excited. What was your question?
Do you ever like to do a certain thing, or carve your name into something, or a place you've been?
So leave your mark on a place you've been. I try not to, as much as possible, when we go out exploring and having adventures, and I do a lot of mountain guiding for different people. We have this policy which is leave no trace. So wherever you go, you're not supposed to leave any trace that you've been there. So that goes for fires, it goes for rubbish, and it also goes for carving your name and stuff. There's a great thing around the world called geocaching, which you might have come across, and your teachers might have come across, where you go, you use your smartphone, and you go out there looking for places other people have been, and they might hide stuff like under a rock or up a tree, and other people find it, and you take that thing and you leave something else. So it's a kind of like a secret way of leaving your mark on things. So have a look for it. It's called geocaching, and it's a good way of leaving no trace, but also leaving your mark. Great question, Carter. Thank you so much.
Thank you.
Okay, we're gonna come over and grab a few from my 6-7s. Mackenzie, do you want to start us off? Come on up.
Okay.
Don't be shy.
Where's Mackenzie? Oh, hi.
What is the coolest adventure or finding that you've done?
The coolest adventure or finding that we've done. Do you know, when we were in the Alps this summer, it was quite a cool place to be, and we spent a little bit of time out there before we actually got on to making our educational resources. And by the way, teachers, all our education resources are online. I'll get Ms. Grabowski to send them around later. But all the stuff we did out in the Alps was brilliant, because we were there and we'd been there for a few seasons already, so we got to look at a lot of different things in the Alps that we'd seen before. And we got to, and I'm just going to have a quick look for that picture, got to see a part of the Alps that was quite special to us. Is this one here, and I'll share that screen over with you guys. This is somewhere called the Tor Basin in the Alps, and it's the Tor Glacier. And this glacial snout is the end of the glacier itself. When we were there, say 5 years ago, it was a lot further down the valley towards the valley floor. And it was astonishing to see that this glacier had retreated so much in the last couple of years since we'd been there. And when you go to glaciers and find that they're retreating, it gives you a real sense of we're really changing this planet and we need to do something about it. So for me, I went to see I've been up in the Norwegian fjords and been up into I was recently up in the Alaskan fjords as well. And you see these glaciers and how they change. And for me, that's one of the best things I've done. Is it really hit home how much we're changing the planet and how much we need to save it. Thanks, Mackenzie.
Okay, sorry, Huw, they're just doing an announcement, so we just need to pause for just a moment.
Oh, cool. I wonder what the announcement is.
Amelia, Megan, and Olivia.
Someone's been naughty.
There will be a three-team meeting today at 11:55. Meet Mrs. Drummond in the library.
It's still so early out with you guys.
Take Me Outside Day has been canceled due to the
Almost there.
Please try to get outside.
We don't have announcements like that in our schools. We don't really have a tannoy system. We should. I think they're better.
All right, there it is. Peyton, come on up.
When you visited the glaciers, what did you see happening to them?
So when we visited the glaciers, let me see if I can bring that one up too. We went out to, in Alaska, something called the, let me see if I can bring that up. We went to look at the different glaciers, and in the glaciers themselves, you have a quick goosey gander. You wouldn't believe how much stuff is on all of my computer. So, where are we to? Juneau, Ketchikan, well, lots of different places in Alaska. It's a lovely place, and I know that you guys well head across. We went to Vancouver as well. Again, really, really beautiful. So one of the things that we found was that we couldn't go too far up towards the glacier itself because it was so warm. The whole snout of the glacier kept carving. So we couldn't actually get right up to the glacier. We normally, like in the old days, you'd be able to get right up to a glacier and you'd be able to well, to almost touch the wall, because it's so so docile, and by docile I mean, you know, it's not much carves off it. When we say carves off it, not much falls off it. I was just going to show you quick our view off the front of the ship we were on when we were there. This was the front of our ship, and you can kind of see the glacier in the background as we're starting to turn a little bit, and you can see how much debris, how much iceberg is in the water at that point in time. So lots of debris in the water, lots of stuff happening, and actually when we were there, all these bits of iceberg stopped us from getting any closer to the actual glacier. And normally we wouldn't see this. Normally we'd see through this period of time, we could get it right up nice and close because because it's still cold. But actually on this particular day, it was so warm, stuff kept falling off, and the glacier was actually, well, carving a lot more than we thought it was. So, like I said, you get an idea of how we're changing the planet. Glaciers are a great representation, or I suppose a bad representation of what we're doing to the planet. So, for me, volcanoes and then glaciers are perfect things to explore. Thank you so much.
And one more question from our end. Come on up.
Oh, nice pattern. Hi there. Oh, that's a cool top.
Thank you. I'm Kaylin, and I was wondering, on the paddle trip, on the river trip, did you ever fall off the paddleboard a lot?
That's two different questions, that is. Did I ever fall off, and did I fall off a lot? And the answer is yes to both of them, actually. I did fall off a lot, and I did fall off every now and then. But on our rivers, they tend to be fairly short, but also a little bit more aggressive. So lots of, we call it white water. And the white water on our expeditions is things we kept falling off. Actually, in things like canoes, would have been a lot better. Like Canadian canoes are the thing to do river expeditions on, because you can turn them over and portage them, like carry them on the shoulders a little bit easier, and also you can strap lots of things to them and put stuff inside to keep them dry. On our expedition, on our stand-up paddleboards, we didn't have that luxury, because our paddleboards, they were 12 foot long, and we had to stand up on them as we were paddling. So what we found on that expedition itself was that what we'd be doing is paddling for X amount of hours per day, and what we were doing with it, we were paddling, and I'll show you a quick clip of the type of training that we were doing for this. The training we were doing in hailstones. The weather in Britain isn't great anyway. This was in winter we were training. So there was a thunderstorm when we were training for this expedition, and we were getting hailed on, but it was all good preparation. But it meant that we fell off a lot. The weather wasn't particularly great. On our actual expedition, the weather was a lot better. But when you are going down white water and rapids, then you do fall off quite a lot. So the answer to both your questions is yes, I fell off all the time. Thank you so much.
All right, well, Huw, thanks so much. We had a blast today. The other class would say the same thing, but I'd love to just give you, if you want maybe a final message or just a sign-off for the students, then I'll turn the mics on so they can say goodbye, all the classrooms together.
Fantastic. Yeah, definitely my sign-off is, if you get the chance, and I know there's a fantastic company in the US called REI, and they're an outdoor, you might have come across their shops. This Black Friday coming up, which is the Friday everyone goes out and has sales and whatnot, this Black Friday, they're actually doing something called Opt Outside, which means no one goes shopping and everyone goes outside. And if I could encourage you guys to do anything, it would be to go outside more, explore more, and keep asking that question. Keep asking the question why, and being curious about stuff. Bug your teachers every single day, asking why does that happen? Why does that happen? And you know that you guys got great teachers, and they'll sit down with you, or point you in the right direction and say, let's work this out together. or you can go off and find this out by yourself. But always be curious and always explore as much as possible, because we've only got short lives, and as much we can see in those short lives is better, and hopefully we can all see that kind of stuff together.
All right, great sign off. I'm turning the microphones on so we can say goodbye and thank you.
Thank you, everyone. Thank you so much. I'll send around the time lapse of the Coca-Cola experiment and all the different resources, and we'll speak to you guys soon.
Sounds good. Thanks, Huw.
Thanks for Screw Rescue. Thank you all. Cheers, guys.